Good afternoon. Audio check, please.
गुड आफ्टरनून सर।
सब ठीक है विजन?
हाँ सर।
चलो ठीक है. Audio check.
Loud and clear, sir.
Hello. Okay, last time we were doing gas meters. Finished with the oxygen meters. We finished with the tank explosive meter and tank scope diagram.
No, sir, not the diagram. आपने introduction दिया था बस.
Okay, fair enough. Thank you. So other gases which are there on the tankers are carbons, and these are very flammable gas. We started with the explanation of the flammable diagram. We talked about these gases inside of a fire triangle. It is these gases also percentage they are present in a very high quantity on tankers. The side of a fire triangle we cannot do much about. The type of cargoes that the tankers carry, you cannot get rid of hydrocarbon gases. Really flammable. Tank scope and explosive meters are the meters used to measure these gases, hydrocarbons, percentage in volume. Explosive meter is used the gases. We measure the hydrocarbons in LEL form. Know now what is lower explosive limit. Carbon percentage is measured. The carbon percentage is less than LEL. Explosive meters are used. Oxygen percentage has to be more than 11% for explosive meter. Whereas when the cargo tank is inerted and have a hydrocarbon percentage more than lower flammable limit, tank scopes are used. Explosive meters are very sensitive, whereas tank scopes are not so sensitive. For explosive meter, oxygen percentage has to be more than 11% in the sample of the gas sample, whereas for tank scope, percentage has to be less than 11%. Explosive meters are used in a gas-spraying state, whereas tank scopes are used in a inerted state. Working principle is more or less same for both explosive meters and tank scope. In explosive meter, there is a creation of heat. The oxidation is taking place. Temperature goes up. Since as the temperature of the filament also goes up, and when the temperature of the filament goes up, there is an increase in the resistance. Wheatstone-bridge becomes imbalanced, and when it becomes imbalanced because of the difference resistance among the filaments, current starts flowing. Increase in the temperature of the filament corresponds to the percentage of hydrocarbon present in the gas sample in LEL percentage, in the LEL form, and that is measured by, that is also to the amount of current that is flowing to the circuit, and same percentage of LEL is measured by the gas. This is the diagram. This is the diagram. Same diagram is used for tank scope also. This is in explosive meter. This is a special filament mixed with some catalyst and is sensitive to this temperature change. A special filament is used. What happens in tank scope? When you switch on the meter, the resistance of the Wheatstone-bridge, three resistance are same, whereas resistance of this filament is slightly less. So as soon as we switch on the meter, this circuit is in imbalanced state because of the difference of resistance. A small amount of current flows, and as the current flows, of this filament, as it is a special filament with an alloy or with a catalyst added to the filament, it increases of this filament due to the flow of current. As the temperature increases, resistance of the filament also increases. It is directly proportional to the resistance. As the resistance increases, it becomes equal to the rest of the three. All four resistance becomes same. Current stops flowing from there. It becomes a Wheatstone-bridge. No current is flowing, showing the 0% of LEL shown by the meter. That is zero spanning. As we introduce the gas sample, the tube, a sample which has the oxygen percentage more than 11%. As the gas sample is introduced which has oxygen percentage, I am repeating that oxygen percentage has to be more than 11%.
Is this explosive
meter? I'm repeating again and again. In explosive meter, oxygen percentage needs to be
1% LEL.
Be in the LEL form.
Okay.
It should be not 1% LEL. It should be in a LEL, less than LEL, lower explosive limit. In that diagram, we saw 1% by volume equivalent to 100% of LEN, has 100% of the LEN. Remember that it should fall in the hydrocarbon percentage should be less than 1% by volume as far as that particular diagram is concerned. As we know, lower explosive limit and upper explosive limit vary from gases to gases. So it should be less than, the explosive meter is measuring the carbon percentage when it is less than the LEN stage, than the lower explosive limit. The gas sample in an explosive meter is introduced which has a hydrocarbon in a LEL form and oxygen percentage more than 11%. That means in a gas-free state. When the sample of the gas comes in contact with the heated element, oxidation takes place. It gets oxides, and then it further increases the temperature. It increases the temperature, the filament temperature increases more, makes the filament more hot. So as it becomes more hotter, the resistance also will increase. As we said, temperature is directly proportional to the resistance. As the temperature increases, resistance increases. As the temperature falls, resistance also falls. Value of the resistance decreases. So in this case, as the temperature is going up, the filament is further increasing. Its value increases of this filament. Resistance value increases. Wheatstone-bridge becomes an imbalanced circuit again. As it becomes imbalanced, the current will start flowing to the circuit, and that current will correspond to the percentage LEN, percentage of the hydrocarbon present in the gas sample introduced in the sample tube, and that meter will read the percentage of LEL of hydrocarbon present in the gas sample.
Sir, how will it become unbalanced?
When see what happened initially, three resistance are same, this resistance is little less. When we switch it on, current will start flowing because there is a variation of resistance in the circuit. The current flows, temperature of this filament increases, temperature increases, resistance also increases, and at one stage all four resistance becomes the same and the current will stop flowing. So far so good.
Understood.
When the current is not flowing, that means all four resistance are same. Wheatstone-bridge has become a balanced circuit. All four resistance are same and no current is flowing. This is when you switch it on. Now when we introduce the sample of the gas sample, which has an oxygen percentage more than 11% and hydrocarbon is in the LEL form, less than LEL. When that gas sample comes in contact with the filament, due to the heat, there is a temperature there. Due to the heat, oxidation takes place. The gas mixture, sample gas, get oxidized, and due to oxidation, it generates heat. Because of the generation of the heat, the temperature of this filament, as it is a sensitive filament, with the catalyst to this filament, this filament also increases. The temperature increases, resistance also increases, as it is directly proportional to resistance. The value of resistance also increases. Due to the increase of the resistance value, it becomes imbalanced because there is a difference of all four resistance are not the same again. So when the resistance values are not the same, it becomes an imbalanced circuit. When it becomes imbalanced, current will start flowing in the circuit as there is a difference of resistance. As the current always flows from higher resistance to lower resistance, current will start flowing. Current, amount of current that will flow will correspond to the resistance, and that increase in the resistance corresponds to the hydrocarbon percentage in that gas sample. This meter, the galvanometer, will measure the percentage of hydrocarbon present in the sample, gas sample, which has been introduced in a LEL. So far so good.
Yes, sir. All of it.
Tank scope also, what happens in tank scope is more or less the same. Instead of increase in the temperature, the decrease in the temperature. The gas sample is introduced. Gas sample in tank scope, the percentage of the oxygen is less than 11%. Carbon percentage is more than lower flammable limit. That gas sample goes in, and the filament also is not a special filament. It's a non-catalytic. There is no catalyst added to the filament. That gas sample in the tank scope goes through the sample tube. Gas sample has a less than 11% of oxygen present in it. Carbon percentage is high. Then lower explosive limit, low more than LEL. So when that gas comes in contact with this heated filament, it absorbs the heat because oxidation cannot take place because oxygen percentage is not more than 11%, it's less than 11%. So it absorbs the heat. As it absorbs the heat, temperature of the filament goes down. As the temperature of the filament goes down, resistance value reduces. So as the resistance value reduces,
सर एक बार ये रिपीट कर दीजिए कि मतलब
सब
जब गैस
सब रिपीट होगा, डोंट वरी, अभी 2-3 बार और रिपीट होना है, डोंट वरी अबाउट इट, ठीक है?
हाँ जी सर
Just try to grab as much as you can, but it will be repeated many times, don't worry. I'll make sure that you all understand on the same page. When it absorbs the heat, the temperature of the filament will go down. As the temperature falls, resistance value also goes down. Circuit becomes imbalanced because not all 4 resistors are same again. It will start flowing. The current starts flowing. The value of the current will correspond to the percentage of hydrocarbon in the gas sample which has been put in the sample tube. Principle is same. In one case, in explosimeter, temperature of the filament is increasing because there is a special sensitive filament used, and in tank scope it is absorbing the heat. Temperature of this filament is going down. In both cases, the Wheatstone-bridge is used. Only the difference of the filaments. One has a special filament, the catalyst added to the filament becomes sensitive to the temperature, whereas in other case you have a non-catalyst filament the gas is absorbing the heat, reducing the temperature of the filament. There is a variation of resistance in both the cases. In explosimeter, resistance value is increasing because temperature is increasing. In tank scope, as the gas is absorbing, it is falling, the filament temperature is falling, the resistance value is increasing. And in both the cases, Wheatstone-bridge is getting imbalanced because there is a variation of resistance. Not all 4 resistors are the same. Amount of current flowing through the circuit corresponding to the value of the hydrocarbon value by volume in tank scope and in LEL form in explosimeter. Any question?
चल तो एक कॉमन मीटर यूज करते हैं जिसमें सभी डिजिटल डिस्प्ले होता है और सभी गैसेस का मतलब उसमें एक से ले सकते हैं हम शायद.
या सेंसर तो सब में चाहिए ना.
गैस मीटर के सर वो
हाँ.
हर एक H2S के और कार्बन मोनोऑक्साइड और सभी के इसमें मतलब सभी की एक से ले सकते हैं रीडिंग्स तो.
हाँ, मल्टी गैस डिटेक्टर्स है ना आजकल.
ये सब वो सेंसर्स सभी के लगे होते हैं, अगर कुछ खराब हो जाए तो सेंसर्स चेंज कर देते हैं.
करेक्ट. वो जो छोटे सेंसर होते हैं ना, they have this circuit. They have this kind of circuits. ऐसी सेंसर थोड़ी काम करने लग जाएंगे ना. They have to comply with some principle. The instrument is one, but they have a slot for each sensor. Usually they are measuring 4 gases at the same time. Multi gas detectors कहते हैं उनको. But principle, each sensor is having its own principle. It's working on that principle. ठीक है?
Okay sir.
Any other question? Usually the question asked in MMD define the difference between the tank scope and the explosimeter. There we can give explanation how the explosimeter functions, what are the difference in filament, what exactly it is measuring. When it is explosimeter, oxygen percentage should be such, when these meters should be used on board, and what condition these meters should be used. You can explain the whole thing. Principle of explosimeter, principle of tank scope, condition of the cargo tank when we are measuring explosimeter, and condition of the cargo tank when we use tank scope. Explosimeter is sensitive, it's not. Type of filament is used on explosimeter, the catalyst type, whereas in tank scope it is not. It is non-catalyst. Explosimeter measures the gases from below when the hydrocarbon percentage is less than lower flammable limit. Tank scope measures the gases when the carbon percentage is more than flammable limit. These are the difference between explosimeter and the circuit that is used. What is happening in the circuit also we can see. In explosimeter, the temperature of the filament is going up, oxidation, whereas in tank scope of the filament is going down as the gases are absorbing the heat, and as it is absorbing the heat, and then you have the working principle. These are the difference between meters and scope. Yes, You are right that you have multi-gas detectors nowadays on board. We don't have individual meters nowadays. We don't have one meter you carry and all problems are solved. We need to understand the principle of those sensors. They function on these. They have a small Wheatstone-bridge inside. One sensor is measuring same tank scope, working as a tank scope, and one working as an explosive meter. Same sensor has a two circuit inside the same sensor. Okay, so we'll go through the any other question, guys, before we start going through the PPT.
अगर हम एक्सप्लोजीमीटर को अगर हम ऑक्सीजन लेस देन 11% पे यूज करेंगे तो वो करेक्ट रीडिंग नहीं देगा।
हाँ, करेक्ट रीडिंग नहीं देगा, इट विल नॉट वर्क ओनली, क्योंकि अब वो ऑक्सीडेशन तो होगा नहीं, इट विल नॉट वर्क ओनली।
सर, अभी जैसे हम मल्टी गैस डिटेक्टर यूज करते हैं और जब वो एलईएल से ज्यादा होता है, थोड़ा मतलब वॉल्यूम में कन्वर्ट हो जाता है वो अपने आप ही।
हाँ,
बट क्या रीजन हो सकता है?
सेंसर खराब हो सकता है। सेंसर खराब होने की बहुत चांसेस है, बहुत कारण है। मे बी बिकॉज ऑफ सम अदर टॉक्सिक गैसेज आर अराउंड, सेंसर खराब हो जाता है। इफ यू यूज दैट सेम एक्सप्लोसिव सेंसर इन अ inerted state or tank scope in a high oxygen gas being state, sensor can damage, but not so much. Oxygen sensors are getting damaged more and more than the explosive meter and tank scope. Am I right? Very often you're changing oxygen sensors. Most of the time you're changing oxygen sensors. Very rarely you change these other sensors. कोई डैमेज नहीं होता, दे आर वेरी स्ट्रॉन्ग, कुछ इसमें डैमेज होने की बात सीन है नहीं। एनी अदर क्वेश्चन गाइस? So I told you the difference
जब
between
हमें
the
पता हो
explosive.
कि
बोलो।
अभी भी वॉल्यूम में है, मतलब टैंक में गैसेस वॉल्यूम में है हाइड्रोकार्बन, तो हमें क्या प्रेफर करना चाहिए सर, पोर्टेबल वाला कि वो जो एक कैरी करके जाते हैं?
Always पोर्टेबल वाला। कैरी करने वाला इज नॉट फॉर मेजरिंग। वन इज पोर्टेबल गैस मीटर एंड कैरी करने वाले को कहते हैं पर्सनल गैस मीटर।
हाँ जी, एक पर्सनल और एक पोर्टेबल। हाँ जी।
हाँ, you carry it, you don't measure cargo the gas percentage. You always use portable meter for measuring gas percentage, always. Personal gas meter is used when you're going inside the tank. क्या?
वो एक ऑफिसर रिकमेंड करते थे कि वो सेंसर ना खराब हो जाए तो पर्सनल वाले से करो पहले।
पता नहीं कौन कौन सी अपनी थ्योरी लगाते रहते, बिल्कुल गलत है। पोर्टेबल आर मेंट फॉर
बांध
मेजरिंग।
के टैंक में लोअर कर देते थे,
एक दिन वो वहीं से गिर जाएगा एंड सुहा हो जाएगा उसका।
हाँ सर, वो रस्सी बांध के लोअर करवाते थे।
ऐसे लोअर तो नहीं करते थे हम, वो ऊपर ही पीवी में उसका कनेक्शन था ना सर, तो
हाँ,
हम
हाँ,
उसी से ही कनेक्ट कर देते थे और एक आउट करते थे, ऊपर एक ऐसे वेंट सा बना होता
हाँ, हाँ।
पीवी में।
नहीं, एब्सोल्युटली रॉन्ग। बताओ क्या क्या करते थे, आई कैन गिव यू द सॉल्यूशन फॉर ऑल दैट। एटलीस्ट वी कैन स्टॉप ऑल रॉन्ग प्रैक्टिसेस।
सर तो
बहुत
सर
wrong।
तभी खराब होता था।
हाँ, खराब तो होगा ही वो। इट्स गॉट नथिंग टू डू विद दैट। उसमें ऑयल चला जाएगा, या अगर तुम इतने हाई प्रेशर में करोगे, मे बी सम स्प्रे इज कमिंग फ्रॉम द पीवी वाल्व, उधर में मे बी दिट विल डैमेज, सम ऑयल कंटेंट माइट गेट स्टक इन दिस filament this sensor, will damage the sensor. But personal meters are only for for people those who are going inside, so that जब वो नीचे है, अंदर कार्गो टैंक में है, if gas is there, the alarm will be activated and they can escape. That is the purpose of personal gas meters. Normal monitoring of the gas atmosphere, always meter, always. कहाँ से सीख के आते हैं तो पता नहीं कौन कौन सी थ्योरी।
सर पर ये जो पोर्टेबल वाला होगा वो वैसे काम नहीं करेगा क्या, अगर मान लीजिए नीचे ले भी गए लोग?
हाँ, क्यों नहीं करेगा। पोर्टेबल है ना, थोड़ा सा हैवी होते हैं, थोड़ा लार्जर इन साइज। इट्स नॉट सो डिफिकल्ट। इफ यू डोंट हैव पर्सनल, यू हैव नो चॉइस, ये तो लेना ही पड़ेगा। बट यस, फंक्शन इज सेम, बट पर्सनल मीटर्स आर मेंट फॉर पर्सन दोज हु आर गोइंग डाउन।
हाँ जी सर, सबका अपना हो जाता है फिर।
सबका अपना हो जाता है, फॉर देयर सेफ्टी इट इज। पर्सनल गैस meters are meant for their individual safety.
सारे रिक्वायरमेंट क्या है सर इनकी गैस
लॉजिक दिया
मीटर्स
था
की, पर्सनल गैस मीटर्स की?
See, one at a time, please. Go ahead.
ये इनकी रिक्वायरमेंट्स क्या हैं गैस मीटर्स की और पर्सनल गैस मीटर्स की, कि मतलब टैंकर्स में कितने होने चाहिए और बाकी नॉर्मल शिप्स में?
मैंने बताया तो था इसमें फर्स्ट डे में।
5 होती है ना सर पर्सनल की, और पोर्टेबल 2।
There should be a provision to measure, ये बताया था ना 16 का requirement. All ships of 500 gross tonnage and above engage in international voyage to carry portable atmospheric testing equipment on board. Portable, not personal. Portable, all ships, not tankers. We're not talking about tankers. All ships must carry. And these meters must be capable of measuring at least these 4 gases: hydrocarbon, oxygen, carbon monoxide, hydrogen sulfide. सोलास का रिक्वायरमेंट ये है फॉर ऑल शिप्स एंड दैट मस्ट बी द कंपनी स्पेसिफिक रिक्वायरमेंट की मिनिमम 4 होने चाहिए, ये होने चाहिए, वो दैट इज कंपनी स्पेसिफिक रिक्वायरमेंट और मे बी oil majors requirement. But as far as SOLAS is concerned, we must have instrument measuring all these. Provision should be there for all ships. Okay. So that's any other question, guys? Very important. These meters must be calibrated. I have explained enough on that. Calibration is really important. Meters. They must be working properly. My decisions, master's decisions, are totally relying on these meters, whether to send the people down in their enclosed space or not. Minimum people, we all know, minimum people must go inside the cargo tank or inside the enclosed space. Minimum
minimum 2 people.
और एक बाहर
minimum
होगा.
और एक बाहर हो गया, minimum 3 हो गए. People are required. It is as per the procedures. Exactly is happening. What actually is happening, practical happening. No third person, which is a standby person, and most of the time only single person inside the enclosed space. Am I right?
Yes, sir.
80% should be less than 0.1% LEL, no sir?
Man entry?
Yes sir. It should be less
1%.
than 0.1% of LEL.
1% LEL. 1% LEL. ठीक है. Oxygen percent should be 20.8. Toxic gases should be in TVL state, limit condition, 0. LEL should be 1%. The hydrocarbon should be 1% of understanding what I'm saying. Percent LEL था, उसका भी 1%. Not 1% by volume.
सर पर वो
1% of
इतनी
LEL.
इजीली नहीं आता सर 1%, मतलब काफी बार उसको हाइड्रोब्लोअर से काफी देर तक करना पड़ता है, उसके बाद ही आता है वो.
10 तक आ जाता है आराम से. After from 10 to 1 it takes very long time.
सर 10 से नीचे तो आ जाता है, पर 1% लाना काफी मुश्किल हो जाता है.
But हाँ, safety of the people is more important. No, time तो लगेगा. So most important that these meters must be giving good readings, correct readings to me. Then only I can ensure people's safety. Well, for those who are going inside the enclosed space, their safety can be ensured. For that purpose, the calibration must be carried by use, and you have a monthly maintenance also for this. Plan and maintenance schedule is also there for these meters as per the company, as per the manufacturer's instructions must be followed. You have multi-gas detectors these days, which are measured out of these 4 gases. They are measuring 4 gases. Each meter multi-gas detector must measure oxygen and carbon. Other 2 gases can be anything: carbon monoxide, dioxide, hydrogen sulfide, sulfur dioxide, anything. But these 2 gases must be there in each meter multi-gas detector, oxygen and hydrocarbon in a LEL form. Any other question before I start PPT? So PPT is just a repetition of what I said. Hope you all have drawn the diagram. You all have received the tanker notes, right?
Yes sir.
Okay.
Yes, sir.
Right. Thanks. So explosimeter is just a repetition I have spoken so far and a revision for you all. Sensing element of CFCG, catalytic filament combustible gas indicator, explosimeter. Be a catalytic filament heated by an electric current. Very sensitive filament used, which can be heated by a small electric current also. Very sensitive. Some instrument, the filament is replaced by ceramic pellet with a catalyst, but the mode of action is the same. Filament, they use this ceramic pellet, but the purpose is still the same, that it gets heated up with the electric current. When a mixture of hydrocarbon gas, air drawn over the filament, the gas oxidizes hot filament, makes it hotter, meaning it increases the temperature. It gets oxidized because the sample gas has her oxygen percentage more than 11%. Because of that, the gas get oxidized, and because of the oxidation, the temperature hot filament becomes more. The heat is generated, and which makes the filament more hotter. That means it increases the temperature of the filament due to oxidation. This increase in resistance, filament become hotter, its resistance value increases, Wheatstone-bridge becomes imbalanced, current will start flowing through the circuit. Increase in resistance and the change of resistance provides a measure of concentration of gas in the mixture. Flow of current indicates the percentage of hydrocarbon present in that sample gas. This meter relies on presence of oxygen. As I said, minimum oxygen required for explosive meter 11% by volume to operate efficiently, and for this reason flammable gas mixture should not be used for measuring the hydrocarbon gas in an inerted atmosphere. It should be in a gas-free state. 11% of oxygen minimum required. It be more than that, but minimum required is 11% of oxygen by volume. A simplified diagram of the electrical circuit of CFCG indicator is shown in the figure. It is Wheatstone-bridge with the sensor filament forming one arm of the bridge. This is the one arm of the bridge. Indicator is made ready. Hope you all have drawn this diagram. Indicator is made ready for use, balancing the bridge with filament at the correct operating temperature in contact with the fresh air. When you switch it on in the fresh air, temperature of this filament increases little bit, and once it becomes balanced, it gives a 0 reading. When you switch it on in the fresh air, that's what happens. The temperature of this filament increases, and once all four resistance becomes same, no current is flowing, Wheatstone-bridge becomes a balanced circuit, and it gives the 0 reading on the meter. Increased resistance of the sensor filament about by combustion of the sample mixture throws the bridge out of balance again, causes the meter to deflect by an amount proportional to the combustible gas concentration. The sample of the gas is introduced, gas sample which has high percentage of oxygen. When it comes in contact with this heated filament, the gas gets oxidized, makes it more filament resistance more, increases the resistance, makes the filament more hotter, and because of the increase in the temperature, resistance increases, and it makes the Wheatstone-bridge imbalanced. It becomes imbalanced, the current starts flowing in the circuit. The amount of current corresponds to the percentage of hydrocarbon present in the sample gas in a LEL form. The galvanometer at the center will give the reading of LEL of hydrocarbon, the sample gas. It is shown on the scale calibrated from 0 to 100% of LEL or LFL. This instrument incorporate additional to give a second expanded range from 0 to 10 LEL also. So as somebody mentioned just now, it takes very long time to bring the LEL from 10% to 1%. Some instrument they have a special circuit. Nowadays you have so they don't have any separate circuit for that. But if you have an individual meter for explosive meter, it might be a smaller scale provided, another scale provided to measure from 0 to 10% of LEL. To maintain consistent reading, the voltage across the bridge must be constant, and a control is provided for this purpose. That's how the tank scope. That would be just gone through the explosive meter. Individual tank scope used to look like this. Nowadays you have a multi-gas meters, very reliable, sensitive, work with, easy to operate. Operating principle: sensing element of this instrument is non-catalytic hot filament. Catalytic composition of surrounding gas determines the rate of loss of heat. In this case, in tank scope, there is a loss of heat from the filament, and hence its temperature and resistance also reduces. As the temperature and resistance of this filament reduces, the bridge again becomes imbalanced. The current will start flowing, which will correspond to the percentage of hydrocarbon present in the gas sample in volume. So on the same principle as explosive meter, except that the gas does not oxidize inside the sample chamber. There is no oxidation taking place because the oxygen percentage of gas sample, because tank scope is used in an inerted state. This gas explosive meter is used in a gas-free state. So when it is in the inerted state, oxygen percentage is less than 11%. Oxidation will not take place. There is an alteration of temperature heated filament due to composition of surrounding gas. Sample gas absorbs the heat. It comes in contact with the heated filament. It absorbs the heat from the filament, and with the result, it reduces the temperature of the filament. And the rate of loss of heat from the filament is temperature and resistance. So as there is a loss of heat, temperature of the filament goes down, and as the temperature goes down, resistance of the filament also reduces, which Wheatstone-bridge become imbalance. Current will start flowing in the circuit, which amount of current will correspond to the carbon percentage in the gas sample volume, and the meter installed there will give the carbon percentage by volume. Sensor filament forms one form of the Wheatstone-bridge. The initial zero operation balances the bridge and establishes the correct voltage across the filament, ensuring the correct operating temperature. During zeroing, the sensor filament is purged with air and inert gas free of hydrocarbon. There shouldn't be any hydrocarbon. When you're putting in the zero reading, it should be done. When you're switching it on, it should be done in the fresh air. There should not be any presence of hydrocarbon. And this instrument is not as sensitive as explosimeter. As in CFCG indicator, there is a second identical filament in other arm bridge which is kept permanently in contact with air and act as a compensator filament. The presence of hydrocarbon changes the resistance of the sensor filament, and this is shown by deflection on the bridge meter. Now it is clear the rate of loss of heat from the filament is non-functional of the hydrocarbon concentration, and meter scale reflects this non-linearity. The meter gives the direct reading of percentage by volume. Explosimeter measures the percentage of LEL. Tank scope measures the percentage by volume of hydrocarbon. Okay. Other gases which are present, other meters that you have is hydrogen sulfide gas, very common these days. Carbon monoxide, again very common. Your multi-gas detector, how it looks like. 4 different gases, 4 sensors will be there inside, measuring 4 different gases. One is oxygen, another is hydrocarbon. This is LEL, you can see that. This is carbon monoxide, and this is your hydrogen sulfide. Other than these gases, there are other gases also, which, as I have spoken, enough of this calibration and testing must be done at a regular interval as required by the manufacturers. Be carried out as per the manufacturer's instructions. Be regularly calibrated. Other than these gases, you have some toxic gases also present on tankers. Very small concentration of these toxic gases are present, and there should be some instrument to measure these gases as well. The concentration of these gases are very less. Chemically coated indicator tubes are used to measure. Chemical indicator tubes are used to measure these toxic gases. Whatever toxic gases are there on board in the cargo, we must have provision to measure those gases. So we must have these tubes, chemical indicator tubes for each of those toxic gases which are listed in MSDA sheets, material safety data sheets of that particular cargo, so that we must have the provision, we can measure those presence of those gases in the cargo tank when we are doing the gas filling. Popularly known as Dräger tubes, and this is a hand pump known as Dräger pump, are used to measure the low concentration of toxic gases, which are nothing but chemical indicator tubes provided. Dräger is the name of the company who manufactures this. That's why they are popularly known as Dräger pumps and Dräger tubes. Yes, go ahead.
So this pump we call bellow pump also, no?
Yes, actually it is called bellow type fixed volume displacement hand pump. It's
Okay,
basically it's a bellow pump, but popularly known as Dräger pump, hand pump, but it is bellow type fixed volume displacement hand pump. There's instructions there
yes, sir.
how much you must press it so that one stroke, and there's an indicator also. One stroke is completed, it will give an indicator on that hand pump.
We had this, like we were also having this bellow type fixed volume displacement hand pump, but we were also having this electrical driven, like all these strokes and all, you have to just scan this barcode which is printed on like outside the cover of this Dräger tubes. You have to just scan it and then it will automatically do.
Oh, okay. All right. That's a different type. Okay. Most of the ships, with what kind of vessel was that?
Cruel gas.
Okay. Good. That is the latest version that is coming on. Most of the ships still have this hand pump. Bellow type fixed volume displacement hand pump is known as. Chemical indicator tubes are used to measure the low concentration, very low concentration of these gases like benzene, mercaptan, carbon monoxide. Sometimes you have them. Tubes must be there on board. First of all, we must know what kind of gases are there in the cargo through the MSDA sheet. Once we know that, we must have these indicator tubes on board. These are very particular, very important, especially on a chemical tanker, not so important on crude carrier. As far as chemical tankers are concerned, these indicator tubes must be there for all kinds of gases present in the cargo tank. Other than this, you have a fixed installation also. Gas detection system also installed on board. Measuring fixed 24 hours. These instruments are fixed. These instruments are measuring the gas percentage gases in that individual compartment. All ballast tanks have a fixed gas detection system. Cofferdam, void spaces, room. Some ships you have it on the bridge also. Cargo control room, accommodation, AC duct, and in the pump room. All these places, other than this portable equipment, they also have the fixed gas detecting system installed on board, continuously monitoring these areas, keeping a check on the presence of these gases. So many safety measures in place to protect people on board. We stop it here. Any question?
Hello?
Bolo.
Sir, does the number of pumps vary with the height, sir? Height, like we have to measure the gas at 18 meters, so we will have to do more number of pumps.
It will be written in the, I don't think so. It is written in the tube. How many each tube requires a stroke for measurement. Either one stroke or two stroke. No, nothing like that. It's not like that you have to keep pumping that because it's the gases are coming from right from the bottom. It will be written there for each length how much stroke is required. So it will be written in the tube only. How much
that tube which we are using, we are actually fitting it at the towards the end starting point only. So when it's sucking the air or something like that, so it will only suck the normal air, but in the tube the air which will be going will be from the cargo tank.
So
The length, no matter how.
I don't think so. It vary on the length. I don't think so because once you use it, you cannot use it once or two strokes. If you keep giving strokes and all, it will damage. It's written there how much strokes are required. It doesn't matter on the length or how much the length you have put in. It just mentions the number of strokes required to measure that particular gas, and each tube is measuring. It's pointing at that particular gas only, measuring that particular gas only. Like for H2S gas, for example, that tube is measuring only H2S gas, and instructions will be there in the package also, and maybe in the tube that how much strokes each tube requires is as per the tube for the measuring as per the gases actually, not as per the length.
Okay, sir.
Any other question before we call today? End the lecture now. We still have one more lecture.
So these retention of tubes, like Dräger tubes, it depends upon company, or there is also some regulations as per SOLAS or this.
No, there's no regulation as such for them for retention. These tubes usually they keep it till the cargo is on board or till the or till you have completed. There's no retention requirement. No, nothing like that. People have their own interpretation and keeping it on board. कि भाई मैंने तो check करी थी these gases were present or not present, or they keep it for vetting fellow that yes we have used this, because sometimes vetting people they ask when did you use these tubes last, so just to show them. Otherwise there is no retention, no regulation for retention of these, not required.